I'm going to look at two examples of the chi-square test. The first one is in checking the design of an experiment, which is where you'll most commonly see a chi-square test used. And this is from the example we looked at in the workshop last week, where we were looking at the results of a study which included a group of women who had been taken out of a larger cohort study, which is quite common. So in the table of participant characteristics, rather than comparing two groups, they were looking to see, are the women who were included in the study similar to the ones who were not included, in case there was any bias in the selection of these women. So we're going to have a look at the smoking status, and we've got three levels: non-smoker, ex-smoker, or current smoker. We want to know, do we have the same proportion across those who are included and excluded? So the null hypothesis is that the proportion is the same, and that can also be worded that the two variables are independent, or that there's no association between being a smoker and being included in the study. So it's a common test to look for differences between groups at the design stage. So a chi-square test can be used with any number of categories. However, Open EPI is set up to work with two levels within each category. So you would have to do this in SPSS. So if we go to descriptive stats and cross tabs, and you should be able to work out how to pop in the variables and tick the right boxes from the workshop notes. So the null hypothesis is that there is no association between smoking status and whether or not they were included. There are no cells expecting a very low cell count, and that's down the bottom here. If we had a problem with cell count, we would get a little warning down here, but in this case it's fine. The p-value is here. The asymptotic significance is really, really high, so we've got no evidence that there is any difference in the proportion of smokers between those who were included and those who were excluded from the study. And if we do a bar chart of that, you can see that that supports that. That doesn't actually look like there's any difference. I would never put this in a publication though. It's too ugly. You'd need to make that a little bit prettier. So let's have a look at another example for the chi-squared test. And in this case, it's for checking the primary outcome of the study. It's not very common to use this on the main outcome because you can't control for other variables in a chi-squared test, and it won't easily give you the odds ratios. And so it actually took me quite a lot of time to find an example using a chi-squared test on a main outcome. There's a link to the article here if you're interested, and let's have a look at what they were trying to find out. So we've got, this is our outcome here, their malnourishment score. So their raw score would have been continuous, so they could have looked at that with, if they were using the raw score, a t-test or an ANOVA, or perhaps a multiple regression if they had some other variables. What they've done is divide it up into, were they malnourished, at risk of undernourishment, and were they well nourished? And the people they were comparing were elderly people living at home and elderly people living in an old-aged home. And I've worded that a little bit differently in the description for some reason. I've said in the home versus in the community. Oh, that's not good for my arm. Put that back down again. And you can see on the table that they tell us that they're doing a chi-square test. So, is there any relationship between where you're living and your risk of malnourishment if you're an elderly person? The null hypothesis here is that there is no association between the variables, in which case we would accept the same proportion of malnourished or at risk of malnourishment in the two groups of people. The outcome is this malnourishment, which has been put into the three levels. And the exposure variable in this case is the place of residence. Put that down and get out of the way. So maybe you're wondering, why didn't they use logistic regression to test this outcome? And hopefully you'll remember that logistic regression can only be used if you've got a binary outcome, and in this case they've got three levels: the malnourishment, at risk of malnourishment, and well nourished. So there are other regression techniques you could use. We're not covering that, but they've just used a chi-squared test for simplicity. So if we have a look at the outcome from this test, and again I'll get out of the way. We have no cells with an expected count less than 5, so that's good. It means we've got enough data and we're not expecting any really low numbers. The p-value is highly significant. That's over here, the asymptotic two-sided significance, 0.000. So we've got very strong evidence that there is a difference in the proportion of those who are malnourished, at risk of malnourishment, and well-nourished between those who are living in the family home and those who are living in the old age home. And if you were looking down here, you would notice that it cannot compute the odds ratios for us because we've got these 3 levels instead of just the 2. So you could calculate them by hand by making one of them the comparison or reference level and then just calculating those odds ratios out by hand. Or you could do a more advanced analysis if you wanted to. Now when you're in SPSS, and we'll have a look at it in the workshops, we can get more information out with this cross tabulation. We can get the percentages done in different ways, and if you're interested in looking at the residuals, we can also get them out here, and that will give us an idea of the differences. But if we just do a bar chart, and I haven't played with the colours so they're looking pretty ugly again, it's pretty clear what the difference is. So in the old age home we have a lot more people who are at risk of malnourishment, and then we have a lot more people who are also malnourished.